Hello all, welcome to the second section for the final exam review. This covers modules 6 through 10. I wanted to remind you that I have pulled these slides out of the previous module, so you might see some differences in the recording volume, some stops and starts, things like that. Please just bear with this. My goal was to make sure you could easily review the most important principles that we covered in the class and those that'll be on the final exam. But what that means is you're going to have to put up with a little bit of messiness in terms of the recording quality. You can always go back and view the original lectures or videos if you want, and as always, please reach out and contact me if you have any questions about a particular topic. Good luck. Okay, here's what I want you to know about risk-based monitoring. Risk-based monitoring is a relatively new trend in the industry. Up until 2011, traditional monitoring involved going to the site every 4 to 6 weeks and doing 100% source document verification. But in 2011, the FDA released a guidance for industry called Oversight of Clinical Investigations, a Risk-Based Approach to Monitoring. And in that they said, we really weren't getting good value out of doing 100% source document verification. It wasn't making patients safer or the quality of the data better. Instead, they said, let's go to targeted source document verification and base that targeting on a formal risk assessment plan. So I recommend you read the guidance. I've got a link to it here. It's a great document. If you are going into project management or monitoring, you need to know it. Essentially, though, you assess risk in advance. You target your review of the site's performance to the areas that have the highest risk potential. You review routinely. You particularly look at protocol deviations and trends. You look for unusual distribution of data at the site, data that's too clean, data that's too dirty, high enrollers, low enrollers, and basically site performance metrics. So risk-based monitoring is a new thing, and it's going to impact data management as well as clinical. The next thing I want to talk about is the scope of the data review plan. The data review plan is the document that outlines how we're going to clean and review the data. It needs to support the goals of risk-based monitoring. So in other words, it needs to be targeted to the same sorts of risk areas as the risk-based monitoring plan does. It also needs to support the goals of the analysis plan, because essentially you're reviewing data to make sure it's fit for analysis. You have to comply with a scope of work. You need to know what you were contracted to do. And in general, you want your data review to focus on the most important data. You want to look for trends and patterns in the data, and you want to proactively manage problems. Some things that you should cover in the data review plan are policies and conventions, either form-specific ones or general ones. You want to talk about all the manual checks you're going to be doing. You want to talk about the programmatic checks, edit checks and validations. If you are doing checks outside of the database, we call these external checks, sometimes they're called SAS or SQL checks, you want to talk about those, what they're going to be checking for, who's going to use them. If you're doing some sort of clinical review where you're looking at the data from a clinical perspective, you might want to describe that in the data review plan as well. Same thing for what we call listing review. Listing review is usually it's a SAS listing that looks at outliers in the data. So there's two highlighted here. For these two patients, they have the two lowest lab values. The lowest for patient 701-1015 was a 34, and then 41. So your listing review is often looking just at outliers. You want to document all of these things in your data review plan. Key variables, that's what it's all about. We always want to look at the key variables. These are typically demography, safety, efficacy, study completion, and dosing data. For the safety and efficacy data, you're going to find these as part of the primary and outcome measures in your protocol or protocol analysis. So in this example, our primary outcome measure or efficacy measure was the prevention of pregnancy, and the secondary measure was the incidence of bleeding or spotting during treatment. Your safety data also is typically going to include your lab data and your adverse event data. So key variables, you want to be thinking about those at every stage of the process. When you're doing data review, you want to look for inconsistencies in the data. Here's a good example. This is a place where we might say, checkbox, did the patient experience an adverse event? Yes, no. And then below that we have a field to record a adverse event. So one of your edit checks for consistencies might be that there has to be a response to the question, was there an adverse event? Yes, no. And then if there was an answer of yes, then at least one adverse event must be entered. So that would be the edit checks that you're programming or specifying here. And then below that you can actually see the text of the edit check program where it says patient reported adverse event present at visit 1, but no adverse event is entered. So you're looking for places where two data fields are inconsistent with each other. So you always want to look for missing data, but again, some data is more important than others. This takes us back to that whole concept of fit for purpose. So in this example, for concomitant medication, we are going to ask whether the patient had a con med, yes or no. So here you can see the case report form fields for that, and then below that we have our edit check specifications where it says you've got to fill in this field. It can't be missing, must be present. But I want to show you that you don't want to tag all fields as required to be present, only the most important ones. And this is why. If you look at this bottom example here, these are two default edit checks. One looks for every missing value in the database, and the other tells you only the missing values that were important enough that you required they be filled in. And you can see the difference in the number between the two. So one way to reduce your queries is to flag those fields that are response required. That way the site's forced to do an entry on them. They're your most important ones, and you're going to have fewer queries flagged for missing data. I'm not going to go in depth into protocol deviations and violations in this course. You're going to be covering these in CLR 430 because monitoring of deviations and violations is a major CRA responsibility. But data managers need to understand what protocol deviations and violations are. Keep in mind that a major component of good clinical practice, or GCP, is adherence to the protocol, and we are all responsible for GCP. Why is it important that we in the site follow the protocol? It's important because the protocol protects the patients in the study and those who may later be taking this product. Remember, the design of the protocol ensures we get the data needed to accurately determine safety and efficacy. Also, the protocol is designed to minimize risk to the test subjects. When we don't follow the protocol, we're basically deviating from it or violating it. Those are the technical terms. These deviations and violations can impact the quality of the data, and they can jeopardize the safety and well-being of the subjects. For example, what if a primary investigator violates the inclusion criteria and includes a patient who is on a medication that is contraindicated for the product you're testing? For example, maybe they are already on a blood thinner and your investigational product is also a blood thinner. Taking both at once might cause the patient to bleed out. Unfortunately for us, the FDA doesn't define what constitutes a violation or a deviation. They just require that we report them to the IRB. Data management is rarely involved with the reporting process. All the same, team members, including data managers, should know what a protocol deviation and a violation is. Because if the data review reveals a trend or pattern of deviations or violations, this needs to be reported to the project team. The project team then needs to identify the root cause of the trend and address it. I want you to understand the difference between a protocol deviation and a protocol violation and be familiar with the terms. There are some commonly accepted industry definitions. The ones on this slide are taken from an article by Norman Goldfarb. I'm assigning the complete article, it's a short one but you need to read it, as part of the module readings. But for now, we're just going to review the definitions. First and foremost, a violation is more serious than a deviation. Deviations are events that don't necessarily have significant consequences, like a patient coming late to a single visit, but violations are things that can have serious consequences, such as enrolling a patient without their informed consent. Let's take a look at how we deal with protocol deviations and violations in our CLR MOC-001 trial. In the image at the top, we see two edit check specifications that relate to protocol violations. The first notes that the pregnancy test must be negative. Remember, the protocol excludes pregnant women in order to protect the fetus. We always worry that our investigational product will cross the placental barrier, causing problems with the fetal development, or that it can cause the woman to miscarriage or abort or develop congenital defects. Allowing a pregnant woman to participate in this trial would be a protocol violation. In the second image, we see that the edit check algorithm number 26 looks for pregnancy equal to 1 or positive. Now, we also know that the protocol says any participant who misses more than 2 oral contraceptive pills in 1 month must discontinue from the study. Again, this is to protect a potential fetus by ensuring a patient does not take study drug and then become pregnant because they've missed the doses. We know pregnancy rises, or the risk of pregnancy rises, if 2 oral contraceptive doses are missed in a 30-day period. If you go back to that edit check specification image at the top, you see that we do have a check that looks for patients who have missed more than 2 doses. In the third image, you can see that edit check number 17 looks for patients who've missed more than those 2 doses and have not been withdrawn from the study. Finally, the image on the bottom is from the study completion form. It notes the non-compliant dose is a reason for withdrawing the patient from the study. So once again, we've closed the loop. We've identified potential violations in the protocol. We've developed our database so that it has the data, captures the data we need to find those violations. We've written edit checks to look for those violations, and we found a way to follow up and see if the violation occurs, if the patient is discontinued as appropriate. When thinking about how you handle deviations and violations, it's important to remember that the overall goal is to prevent them. When we do find deviations and violations, we want to determine if they are one-offs, if they happened only one time, or if there's a chance there could be a trend or pattern. So to do that, we have to determine how they occurred, the root cause, and if we can prevent them occurring in the future. I wanted to include this excellent slide from the University of Cincinnati lecture on preventing deviations and violations. If you read over it, you're going to notice that the emphasis is on an attitude of respect for compliance and, as always, the importance of training. While we're on the topic of prevention, I want to remind you that one of your assigned videos illustrates how Quintiles uses trend analysis in Infusario to identify protocol violation patterns and to address them. So again, the key here is we want to report and acknowledge deviations and violations, but more importantly, we want to examine why they occurred and how we can prevent them from occurring in the future, whether that's a change in the database, the CRF, the protocol, or the training of the site.